Hello. This video is about problem 2 in chapter 4. I've received this request from one of the students here, so I appreciate you guys asking questions. I am more than happy to make videos and explain the concepts for you. In this question, the city of Minneapolis is considering building a dam at a cost $5 million. So the initial cost for this project is $5 million. The estimated reconstruction. So please correct that in the problem. So reconstruction, upgrading cost is $1 million every 5 or every 50 years. So what we could do here, what we need to do, we need to find the capitalized cost if interest rate is 9%. So again, before we start, I need you guys to correct the language of this problem 2, and I apologize again, this is a pre-print for the textbook, so I haven't had the chance to review it or proofread it. Anyway, just please correct that. So the question is $5 million upfront, that's the initial cost. Every 50 years we need $1 million to maintain this project. And what we need to do, we need the capitalized cost. And the capitalized cost, it is present worth for infinite projects. So if we have a project that will last forever, we need to find the capitalized cost. We can't do the present worth. So in order to do this, we have to put down all the information from the question. So P is $5 million, and this is in a present format. There's no need to change it. Just add it to the equation. And the other number that we have is a 1 million every 50 years. And how we could handle this, this is happening in the future, and it is happening every 50 years. So what we have to do, we have to find A for that. So the equation for the capitalized cost would be initial cost, the initial cost plus the whatever recurring expenses. Like this expense happened every 50 years, so we have to consider it. Before we do this, we have to convert it into a factor, which means an annual expense. What would be the annual expense for these expenses? We know this is every 50 years we have to pay 1 million, but if we need to estimate this per year, how much would cost us? So first of all, let's find the equivalent annual expense for the 1 million, and this could be calculated by the function, the payment function, using 9%, 50 years, and the future value is 1 million. And double check that you have the correct number here. So we have 3 zeros and 3, this is 6 zeros, so 1 million in here. So instead of paying 1 million every 50 years, we could do $1,226 every year. Now, since we already have the equivalent for the 1 million, now we add the 5 million, the initial cost, which is already in the present value, plus the A over I. So plus the annual expense, which is what we have here, 1226 divided by 9, and this is how we calculate the capitalized cost. Again, it all started from the capitalized cost equation is A over I, but in this question we have a present worth, the initial cost. What we have to do with it, no need to do anything with the present worth. It is already in a present format. You use it as is. As you see here, we use it as is here, as in F4, self F4. For the expenses that happened every so often, like every 50 years in this question, we have to pay 1 million. What we need to do, we have to convert it into a present format, but before we convert it into a present format, we have to change it into an annual format, and we use the payment function here as a way to convert it from future format every 50 years to an annual format every year. And we use the PMT, open parenthesis, 9%, 50 years, and a 1 million, close the parenthesis, and that will give you a 1226.87 cents per year. Now, the next step is to find the capitalized cost. Apply the capitalized cost equation. You add the initial cost plus any annual expenses. Divide the annual expenses by I to convert it into a present format. And this is what we have F4, which is the 5 million plus the annual expenses divided by I, and that will give us a 5,013,631.87 for this project. I hope this is helpful. Thank you so much, and please let me know if you have more questions. Thank you.